under C, I'll go ahead and browse the directory over there. So C Unreal source, go ahead, extract and extract it under that directory and hit OK. Now we're just a few steps away in order to install Unreal Engine. So first of all, go ahead and run your setup batch file and try to run it as an administrator just to ensure it has all the permissions for everything. So run the setup batch file as an admin. So something like this should show up, and once it's completed, we'll head into the next step. After the setup batch file has completed running, you can go ahead and run the generate with project files.bat. So this file is basically going to generate your Visual Studio solution. So let's go ahead and run that again. Try to run it as an administrator. Should work regardless, but if you do get any errors, just run it as an admin. So you should see something like this, and this should complete relatively quickly. At this point, you should be able to see your solution file. So go ahead and open it up. Once the solution is open and you see ready over here at the bottom left hand side, what you should do is you should go ahead and head into Engine, and if it does ask you to install a few more components in Visual Studio, make sure you just go ahead and do that, just follow along. But in my case, I've already done that, so I'm going to go ahead, right click on UEFI and click build. Now once your build has succeeded, under your engine, binaries, Win64, you should find Unreal Editor.exe. So by default, the build configuration is set to development editor. If you don't see this, it means your build configuration was probably something else and it didn't get built. So anyways, let's go ahead and open it up, and our editor should load up. If we do get any errors, we can go ahead and debug it now. So everything seems to be working fine, and it is going to compile some shaders. Once that's done, I'll be right back. Alright, so now what I want you guys to do is go ahead and copy your beginner course project, and now I'll show you guys how to change the engine version. So head into your beginner course uProject file, right click, switch Unreal Engine version, and now you should see source build at whatever. So basically I opened and closed the editor, that's it. So whatever we did there, open Unreal Editor.exe, I just closed it immediately, and now I'm back to this location and you should see this. So if I hit OK, it is going to generate some Visual Studio project files, and unless something's horribly wrong, it should in theory work out of the box. So that's about it, and now you can go ahead and just build your solution once again, because there may be a few API changes which you might have to make. So those will be listed in the output log and as well as in the release notes and the documentation or whatnot. So head into your solution. Now we have switched the Unreal Engine version. So now we can go ahead and right click on our beginner course and click on build. So we get our first error here, and this is actually fairly common. So basically we have switched the Unreal Engine version, and we have a plugin over here which is based on the older version of the engine. There are two ways to fix it. One, you can head into the marketplace and reinstall the plugin which is meant for 5.1, or I'll just show you guys the way to do it without using the marketplace. So in the marketplace, it's really easy. You can just go ahead and update the plugin. But over here, if you really want to just use the same one, what you can do is you can head into your engine installation directory. So in my case, it is C, Unreal Source, Unreal Engine Release, Engine, Plugins, Marketplace. It's not here because we haven't yet installed, so you'll find it there. So we'll go to our previous installation, program files, Unreal Engine. This is where I had it, UE5.0, Engine, Plugins, and you should find Marketplace. And the one we are interested in is Low Entry Extended Standard Library. You don't need to copy it to the engine installation, although you could. What I'll do is I'll just take it to the plugins folder over here. So over here, and inside the uPlugin file, we'll do the same modifications. Over here, what we are going to do is under the engine version, we are going to type in 5.1.0. And now if we go ahead and try to build this once again, we shouldn't get that error, hopefully. So it will take a while, and if we do get any errors, we'll go ahead and change it or fix those. So we have a few errors here, and these are mostly the changes which came according to the documentation due to the platform SDK upgrades, but it's not really a problem. So because I don't think any of you guys, unless you guys work for a AAA studio or something, I don't think you'll be using this. And this is from the plugin, this is not something in the engine, so nothing to worry. So what you can do is we can simply just delete this code and just do return false. And even for the Xbox one, so we can just do the same thing. And I'll tell you guys which file this is. It's basically this file right here. So in the error list, you see platform PS4 whatever. So just head into that, just double click on that, and you will reach there. And over here as well, so line 264. So I feel like this was it. So before changing, it was in line 264. So now it's gone a bit up. Anyways, let's try building this once again. And as you can see, the build has indeed succeeded. But once the plugin actually comes for 5.1, what you can basically do is install 5.1 here, like in the Epic Games launcher, install the plugin from the marketplace, and then you can go ahead and copy that into the plugins folder in the engine level. So what you would do is you would have it over here. So C Unreal Source, Release, and Engine, Plugins. Over here you would create a new folder called Marketplace or something, and then you would like just copy it in. Anyways, we are not really worried about that right now. Now what we can do is, now that it's built successfully, we can go ahead and run a debugger, and we should be able to run this in 5.1. So I did show you guys multiple things. So the errors which you get will actually depend on what plugins you are using and how's your code base and what changes are made to the engine's API itself. So depending on that, you'll have to look at the output log and the error list and do something. And there are a few deprecation warnings as well. So if you just have a look. So I'm not really sure what this is, but this will probably be changed soon once the plugin is updated. But right now I'm not really worried since it's just a warning. So now I can go ahead and run a debugger. Alright, so our project has opened successfully, and it is prompting us to change a few project settings in order to actually use virtual shadow maps and Nanite. So that's not really an issue. We can head into the project settings, and over here under, it should in theory be here, so platforms. So let's just search for platforms. It'll be under any one of these. So platforms, Windows, and you can go ahead and enable shader model 6. And over here we can go ahead and I don't think we'll require shader model 5, so that should be about it. And now you can go ahead and restart the editor. Alright, so now I've restarted the editor, and now we are using Unreal 5.1. So that's about it for installing the source and changing your engine version. Now there are a few more ways you can handle some of the things, such as the plugin part, but on the whole this is how you do it. And if you do want any more specific references, you always have the documentation which you can refer, and the release notes, and maybe the Unreal Slackers Discord server. So that's about it. Alright, so we're finally inside the last section of this course, and obviously it is about how to package your game. So it used to be very simple before, so you just go file, package, project, but now you probably have to just do it through the project launcher, which I will show you guys. It's really simple. So head into tools, project launcher, and You can use this, but I'm going to be using a custom launch profile. So go ahead and create a custom profile. And I'll just walk you guys through each option. You can give a name to this profile. Let's say this is for testing. Let's say you're building this for testing, so you can name this profile testing. You can reuse this profile for the next time when you package the game as well. Packaging basically means you make your game or you turn your game into an executable basically. Now project is going to be beginner course, of course, and build configuration. So debug and development will be used when you're actually, testing out your game and you're still not yet at a stage where you can send it to other people. So your print strings and stuff are gonna work. But under shipping, none of your print strings and stuff will work, but it'll take a bit longer to build. And testing is somewhere in between debug development and shipping. So it's below shipping, but it's above development and debug basically. So you can select any one of these. I'll just select shipping. And here, these are settings we don't need to worry about. And about cooking the content, you can do either on the fly or by the book. Basically, what on the fly and by the book is going to differ in is basically if you do by the book, everything is going to be cooked beforehand basically. So if you're packaging your game for shipping, most of the times you will have by the book, and you would select Windows if you're developing a Windows game. Obviously, if you have anything else, let's say you're making an Android game, you would select Android and stuff like that. And under cook cultures, you'll find English somewhere here, so EN. It should be selected by default, so EN. And you can select your maps which you want to cook. So we're using all, so we'll just select all, but you can choose to cook only selected maps. But note that if you don't cook a certain map, you won't be able to open it in game. You're going to get errors. Your game will probably crash. So that's one thing to note. Now, release DLC patching settings. These are some things which I'll not go over. And under advanced settings as well. So you can go ahead and mess with these. So you can enable this if you want all the content to go in a single .pack file. Stuff like that, and everything is pretty self-explanatory. Next, package and store locally. Then you can go ahead and give it a path. So generally I'd like to do it in the project location, saved, and I'd like to create a folder called staged builds. If you've used the project launcher in the older versions, you probably already know what this is. And is this build for distribution to the public? We have selected shipping, so I would assume it is. Of course, it's again your preference. Do you wish to archive? You can select yes or no, doesn't really matter. And deploy, we can select do not deploy because we aren't actually launching the game. So if we select do not deploy, basically you can launch it through the executable itself. So once that's done, you can head back and you can click on launch this profile. So now once everything has been completed, you can head into the directory over there. You should find a Windows folder and you should find your executable right there. So open it up and you should launch your game. So we will end up in this map right here. Again, you can change your project settings and you can change the default map. But anyways, our purpose here was to check if the game packages, and everything seems to be working. The physics simulation works and so on. So that's pretty much it. Okay guys, so this is going to be the last segment of the course, as you guys would know, and I hope you guys would have enjoyed the course till now, and congratulations if you have completed the course till here. And the further part is going to be 2 hours of me creating an entire game. So hopefully you guys will enjoy it. See you in the engine. Alright guys, so this is the last section of the course, and this is not actually going to be about, learning anything new. However, in this part, I will be live demonstrating without any cuts how to make an endless runner such as Temple Run or Subway Surfers or any other which you might have played. So we'll be taking the most simple approach, or at least as far as my knowledge is concerned. If you do have anything simpler, you can let me know in the comments. And hopefully within an hour, we'll be able to make the whole game with the menu, animations, and all that kind of good stuff. So let's get started. So let me actually have a stopwatch here so that we have track of our time. So I'll just create a game. It's going to be third person because we'll have the animation blueprint and stuff. But anyways, I don't think we'll be using that. Not to worry. We'll go with blank actually. C++, and we'll call this one Endless Runner. Create it. Now this will take a little bit of time. And I do have a couple of things being installed in the background, and I also have a list of plugins that I'll be using. So you guys will have a pretty good idea of what we'll actually do with plugins and stuff. Because in the course, I think I just went over these briefly, but I went in depth about how to actually create your own plugins and stuff. Anyways, so our project will be created soon, and this will compile. So until then, we can go ahead and open up our Epic Games launcher, head into library, and we can close this editor for now until we add everything. So what I'll do is I'll go ahead and search these one by one. So city, subway tunnel. So I have to create a separate project for this. Not gonna go over that right now. So we'll go construction volume. So volume 1 and volume 2. We'll go ahead and add this to Endless Runner. We'll add this to Endless Runner. I'll clear the cache later. It's just taking up storage. And we want LE extended. So LE extended. So we have already installed it to 5.0.3. So nothing to worry about there. So adventure character. Whoops. So this will be the character which we'll be using, and it's going to be hella fun. We don't have time to actually model our own character. That's the reason we are doing this. So I'll just go over this real quick. So FX variety pack. Not sure if we will get the effect we need, but I'll just add it just in case. Okay, I need to download it yet, so not gonna do that now. So window dialog box. So I've already installed it. So these two. So we'll use these for obstacles and stuff. And lastly, we'll just have some trees. Maybe at the side we could have something. Stone pine forest. And go ahead and add it. Once everything is complete. Now, depending on your system, if you have a hard drive or something, this process is going to be a little bit slow. So this is under my Unreal projects, Endless Runner. So we'll be using the file explorer for this. I'll just delete this later on. So now once the engine is loaded up, we can start making our game. And we'll go ahead and create a maps folder first. So right click, maps. We'll have only one. And all the obstacles will be spawned at runtime dynamically when you're playing the game. So we don't really care about having multiple maps, but we'll have two. So one is going to be your main menu, and the other one is going to be the actual map. So I'll go ahead and create the map, and I'll call this one game map. Alright, save that and go ahead and open the main menu. Head into project settings and just change that as well. So under your maps and modes, you should have open world. We'll change that to main menu. So editor startup map will be main menu, and it's going to be main menu again. So editor, we can start with our game map actually, but the game has to start from main menu. So just go ahead and click import. Doesn't really matter. Alright, Now over here we can start making a main menu. So right click, create a new folder, and we'll call this one content once again. And inside this we'll actually create stuff because the main content folder is a bit clogged up. So we'll call this one UI, and we can create a main menu. Right click, user interface, widget blueprint, create a user widget, and we'll call this one main menu or BP underscore main menu. And we'll suffix that with a WB to indicate it's a widget. And it's going to be just quick and dirty, so we'll add a canvas panel here. And at the center, we'll just have a start button and an exit button. So we'll add in a vertical box. So vertical box, and over here we can go ahead and make this center aligned first of all. Center aligned position 0 with 0.5 for the alignment value. So this is going to make sure everything is centered. We can go ahead and increase the size a bit, even vertically. And we can go ahead and add in 2 buttons. So button 1 and Control D to duplicate. We'll make it so that it fills it, and we obviously want the play button to be bigger. We don't want our users to exit the game. Anyways, we'll add in the text here. So add in some text, and change the background color for both of these buttons. Make it almost black. Maybe not exactly black, but almost. So I like this shade of color. Now rename this to play, or rather start, we can try. Change the font maybe. So the font we'll use is going to be the light one. So 40 seems about right. Make this one 40 as well, and this one is going to be light, and this one is going to be exit. So we can add the functionality as well because this is pretty simple. So on this button, we'll rename this to exit button, or it's really not required, I guess. So on click, and for this one as well, we are going to add an on click. This is the start button, so I'll just comment this out. And for this, we can go ahead and execute console command, and we can type in exit. Now our exit button should work. We can go ahead and test that. First of all, we haven't even created the widget. So under content, we'll go ahead and create a new folder and call this one blueprints. And we'll have 2 subfolders here. We'll call one as game and the another one as main menu, because we'll have different player controllers and stuff for the main menu and the actual game. So under main menu, right click, go ahead and head into blueprint class and create a player controller. And we'll call this one BP main menu player controller. So this is basically for, creating the widgets and stuff. We'll just use the player controller. Now under the event graph, we can just do it on begin play. So we'll create a custom event, create main menu, and create a widget. It's going to be BP main menu widget blueprint, and add this to the viewport. Now I don't think we really need the reference, but we'll just store a reference to it anyways. So main menu widget blueprint, we'll just have a reference to it, and from this we can go ahead and add it to the viewport. Alright, and on begin play we can create the widget. So create widget, or rather create main menu is the function name. So create main menu, and now if I compile, save it, go ahead and press play. As you can see, nothing happens because we haven't changed the game mode yet. So over here we'll create a new game mode. So go ahead, all classes, game mode. So we'll create a game mode base. So we'll call this one BP underscore main menu game mode. Now under your world settings, go ahead and change your game mode to BP main menu game mode. And over here the player controller can be our BP main menu player controller. And now if I go ahead and press play, we should get our buttons. Start won't do anything, but exit is going to work. Now let's actually head into our game map here. So maps, game map. We'll worry about the main menu a bit later. So we are in the game map. We can go ahead and add our sky. So sky atmosphere, skylight, and we can add in our directional light. We can also have a fog. So we can have exponential height fog, and we have everything set up. Now we could change the time of day as well. We'll make this one dynamic for now. So fully dynamic light, because I don't have any time to actually build this. So go ahead and rotate it to make it like a morning or evening scene. This should be about good. Not gonna spend too much time on it. Save it up. And over here under content, now we can start building the actual level. So I'll just go to my blueprints folder here. Under game, I'm going to create the game mode and stuff for this one as well. So type in game mode. So I'll create game mode, BP game mode. This one is just going to be called BP game mode because this is for the actual game itself. Under your world settings, go ahead and change that once again. So BP underscore game mode. We'll have a CPP game mode if we really require, but I'll try to stick with blueprint as much. Now let's check our time. So 10 minutes in. Now under your game mode, we'll also have a game state to count our score and stuff. So game state. So game state base BP underscore game state. So we have our game mode, and we have our game state. And now we can also have our character and stuff. So we can create that. First of all, we can just right click, blueprint class, character, and we can type in BP character. Open it up, and we have some basic things already set up. For this mesh, we'll be using one of these which we bought under man, under mesh, full. We have all these various options. So we have 4 options. So we'll be using these 4. So these 4 will be the options for the players to choose from. That's how we'll do it. So we'll create a derived class for this, for BP character. So under our characters, what we can do is I can type in character. I'll just move this here and go ahead and type in subclasses. So this is like your main character. So every character is going to be a BP character, but then we'll specifically make them choose a mesh. So go ahead and create a blueprint class, type in character, and over here we can make it of type BP character and call this one character 1. We can actually just name them. Maybe we'll call one Adam. Duplicate that, we'll call one John. I'm just giving generic names. We had 4. So we can call one Jason, and maybe we can call one Bill. I just chose random names. So open this up, and for the mesh we can go ahead and start replacing it. So head into the location where we had the mesh. So this is going to be our first character. We'll set up the animation blueprint a bit later. So it's a bit off, but not to worry. We can go ahead and adjust that. -90. And we can head into the other classes here. So under content, blueprint, game, character, subclasses, we can head into Bill. And this was called SK Manful 1. So we'll call this SK Manful 2. Over here we can select SK Manful 3. So SK Manful 3. And for this one we can have SK Manful 4. So SK Manful 4. So that's pretty much all set. So I'm not sure if I should just use the default one here. So Manful 1. Not sure if it'll inherit the transforms, so I'll just try this. I'll compile this. So if I open the full blueprint editor, okay, it has inherited the transforms. That's a good thing. So we don't have to do everything once again. Alright, so we have our character set up. In our main menu, we can go ahead and add a character selection option. So head into content, our actual content folder. Under the main menu, we can have a button somewhere. And maybe over here, we can type in change character. So I'll change the color of this. I'm not really worried about the visuals as of now. So I'll just go ahead and change this. Okay, I changed the color. So background color, I'll just make this dark again. And we can add in some text. And we'll call this one change character. Alright. Make this a little bit wider so that it's visible for our player. So make this one 45 maybe, or 35. 35 seems good. We'll make that one light once again. Maybe we could make start a bit bolder. So let start be regular, because we want our players to deliberately click start. Alright, so once you click on the change character menu, it should just give us a list and we will create the widget for that. Now we'll also need a game instance class. Head into blueprints, and game instance is general, so we'll create one here. So game instance, go ahead and call this one main GI or something, and under the project settings we can go ahead and change it. So game instance, game instance, change that to main GI, and over here we can have a variable for selected character, and we can change that. Actually we can change that to be of type BP character class. So we have BP character, we should see it somewhere here, BP character class reference. So this is going to be the character which we have actually selected, or we could have it in a struct. We'll think about that a bit later. Now once we have that, we can go ahead and start making the actual obstacles and stuff. So one thing to note is that we want to make this modular in a way. We want to be able to spawn them one after the other. Let's just go ahead and do that. So when the game starts, we want to have a bunch of obstacles, and then we'll look at what to do. We'll work on the obstacles after we work on the animations actually. So we'll head into the skeletal mesh. We have certain animations. So content, blueprint, we'll head into character, and we'll create the animation blueprint right here. So animation blueprint, and we'll go ahead and select our UE4 mannequin skeleton. This is the one which comes with the pack actually. So create, and we'll call this one character animBP. Open it up, and inside this we have a bunch of things. So we'll create a state machine, doesn't really matter. Now we can go ahead and have an idle. So we'll have idle, and we'll create a blend space for this. So right click, go ahead into animation. So basically this is for transitioning between your idle and walk animations. Blend space, and we'll call this one walk run. Okay. Over here we'll have few things in the horizontal and the vertical axis. Horizontal axis is going to be the direction, and the vertical axis is going to be the speed. So we'll go between 0 and 600, but we'll see if we can do something else a bit later on. Now open this, and we can have our third person walk halfway over here. We can have our third person run full way, and we can have our third person idle at 0. So we transition between these, something like this. For the direction we'll have a negative 180 and positive 180 obviously. So this will be like your angle from your forward direction. That's basically what this is. Now we can change the animation blueprint after we actually set it up first. So for the idle, we have our idle animation playing, and we should already have this working. And we can have this as a new state. So walk run. We will set up the conditions, not to worry. Whoops, go ahead and do that. So on begin play, we can go ahead and get the pawn owner and cast to BP character. And we can make this a pure cast because this will succeed. Or if it doesn't, we can go ahead and poll it. And once we get access to our character, what we can do is we can get access to the speed. So get velocity. So get velocity. And we want the vector length. Right now we have a vector and we want the magnitude of this vector. And we can promote that to variable, and obviously the magnitude of the velocity is nothing but speed. So speed. And we can also have direction. So get actor rotation. We'll set it up a bit later actually. Okay, so under the update animation, what we can do is we'll need this on every frame, so we'll use a reference instead. So promote this to a variable and call this one character ref. We'll be using this multiple times. So we can drag this over there. So this will be our speed. And also what we can do is we can also get the direction. So we can use this function known as calculate direction. And that is what will set the direction to be, set direction. So we'll create a new variable called direction. It's going to be a float once again, and we are going to set the direction to be equal to whatever this is. For the velocity, we can just grab in our get velocity here, and base rotation is going to be the actor's rotation itself. So get actor rotation, and we can plug this into the velocity as well. Now what we are basically doing is we are calculating the direction so that we actually input the value correctly in our blend space basically. We are not using this value anywhere else. Oh, here we can plug in our direction and speed. So direction and speed. So these were our vertical and horizontal axis values in our blend space. We can also have jump, which we will do. We don't have a state transition. So if speed is greater than, let's say 10, we can go ahead and transition. And over here as well, if the speed is less than 10, we can transition. So rather speed. So speed is less than or equal to 10. We can go ahead and transition into this state. So now we shouldn't have any of those warnings. Alright, now if I actually create something here, so I'll just create a player start, so we'll know where to start. So player start, and I'll just go ahead and box out a simple level. So shapes, so I'll have a cube, and I'll just make this really big. So this is just for testing purposes, and for the default pawn class I'm going to select BP character. And let's set up the animation blueprint over here. If we go ahead and select our character anim BP, in theory everything should work fine. So our camera is a bit off, that's nothing to worry about. So under our BP character we need to set up a camera, so add a component, and this will be of type camera. Go ahead and add it. We can adjust the view, that's nothing to worry about. And if I go ahead and press play, we have our camera here. So we can make that a little bit further back, maybe tilt it down a bit, and I hope this looks good. Okay, so this looks good. So we have assist none in our character animation blueprint. So that's only in the first frame which is happening basically. So we can convert this to a validated get. That's a simple fix. You can go ahead and turn that into a validated get. Go ahead and press play. And now we shouldn't get those errors. You can set up our movement logic real quick here. So the character is always going to be moving. And I think we might have to change the animation blueprint here, because we always want him to be running, because we don't want him to stop. So we'll always have running actually. So sorry for that, but anyways, it's something we can do. So he'll always be running. So this is how he'll always be. And we can also have, a copy of this. So we'll just copy this over and we can type in run fast. We can make this go at a higher speed. So there should be a speed multiplier somewhere here. So playback speed is what it's called, I assume. So playback speed. So nothing under the details. We'll look into that. So there's actually an option called playback speed. So we are going to increase the speed and make it so that it's actually as if he's running. Now what we can do is we can head into the character once again, and now that we have him running continuously, we'll actually do it so that the obstacles in the world actually go backward. You can create the blueprint for that now. So we're finally heading into the obstacles. So we've spent 25 minutes, not done really that much. Under game, in the blueprints folder, we can go ahead and create a new blueprint class. We'll do it in a new folder. So we'll call this one course rather. This will be the obstacle course basically. And we'll create a new actor. And we'll call this one obstacle underscore base. And we can go ahead and create a child blueprint class and we'll call this one obstacle 1, obstacle 2 and so on. So obstacle 2, duplicate that, duplicate that, duplicate that. We'll have 5. We'll see if it gets too hectic, we'll reduce this number. Over here we'll need some sort of a base. So we can try using some of the things which we got from the content packs. So under hangar, I guess we had a road, I believe. If I type in road, we have this which is pretty tileable, I believe. Over here, road set. We have this. So we can use this. Just that we'll need to know what's the length of this and stuff. I don't think we'll go for nanite or anything. This is fine. So close some of these which we are not using. Head back into the obstacle base. Over here we can go ahead and add in a static mesh. And this will be common for everything. So head back, select that. And go ahead and put that in. So this is there at the origin, but not to worry, we'll find a way to fix that. So it would have been nice if we had multiple lanes, but we have to live with this right now. So I'll just go ahead and recenter this. I'm not sure how big this is going to be. So I think that is pretty well centered. We can go ahead and add in an arrow component just for a reference. So add in an arrow component attached to the root. This one is going to be at the origin obviously. We'll just rotate that for a reference. Or we'll keep the rotation to 0. We'll look into the rotation and stuff. So we'll duplicate this once again. So Control D to duplicate. And we'll just have one over there. I think one is enough, but we'll just have it just in case. Alright, so this is exactly at the end. Now at first we can spawn, for example, 10 of these. And then we can later see what to do. We can have something in the side, by the way. We don't have anything. So we'll just add in a plane. And for this, we can increase the scale of this. Maybe we can make this 100, I guess. Okay, that's a little too big. 50. Maybe change it on the Y. 50 is a bit too much. 40. maybe 30, 35, 32 seems to be about right. So it aligned perfectly here, and it aligned almost perfectly here as well. We can have 32. Now this is approximate, you can do it accurately when you actually do it. So go ahead and duplicate this once again. We'll attach it to the root. Duplicate. This will be for the other side. Alright. So we have something on both the sides. Now if we head into our derived classes, we should also have all of those. So we can spawn this first of all just for testing it out. So open the level blueprint and we can just do a for loop. So for loop, and we can have a loop of length 10, let's say. We'll select an origin. We'll start from a certain point. So target point, we can start here maybe. We'll make the z value of this 0. We'll make the x and y 0 as well. So this is going to be where we start. And we can go ahead and start spawning this further on. So we'll have access to this target point now. So create a reference to target point. So we are going to spawn actor from class and it's going to be BP obstacle. Or I'm not sure what we called it. Obstacle base. This is for testing, so it's fine. So we can get actor location. It's going to be 0, I'm aware, but in case we wanted to change it, the logic should still work. That's why I'm using the target point. So get actor location. We'll break this down actually. Split the struct pin. Now the y and the z are going to remain 0. So I have to see which is the forward axis here actually. So in the obstacle base, we have y as the forward axis. We can rotate everything by 90 degrees if we don't mind. We can just rotate everything by 90. Oops, we change the location. So we can change this to 90. And stuff doesn't seem to be working. We'll have y as the forward axis in our case. Don't mind. So the x value is going to be 0. We are going to split the struct pin. So we are going to multiply this by the index, and we can go ahead and split this, and the y is going to be this. X and the z are going to remain 0. Let's go ahead and just test this out. So go ahead, selected viewport. So if I click F8 and if I were to notice, we don't have anything. So we should have our target. Okay, we are taking the target point's y location, but we need the last obstacle's location. So we need the value of this actually. We need the location of this arrow. So this arrow. So this arrow is going to be located at negative 3200. So we'll just copy the number. We'll just brute force it here. So we have the target point. That's where we start. And into 3200. So it's negative 3200. So I'm not sure if we really need this. This is going to be 0 anyways. So this into 3200, index into 3200. Now let's try this. Okay, so our obstacle course is spawned successfully. So a bit of an issue with the direction over there, but that's totally okay. Alright, so we have that completed. So we spawned our initial course. So we can grab in our player start first of all, and we can rotate that. We can delete one of them. We can maybe rotate that negative 90 degrees. So now we should face the right direction. Now move this a little bit to the left. So for reference, we'll just have one obstacle. So we'll just have obstacle base. We'll set everything to 0, 0, 0, 0. And we'll base the player start accordingly. So our player start just disappeared somewhere. Okay, it's up there. So we'll click end to snap it to the ground. Go ahead and do that. And now we should in theory be centered, hopefully. Yep, we will be centered now. Now if I go ahead and press play, as you can see we are centered. Now we can also set up the logic to move sideways. So we can linear interpolate actually. So we'll add in target points. So copy this over. We'll copy the X location of this. So X is going to be 20. We need 20 here. And the Y location really should be the same actually again. So Y location should be the same. Now we have got these in the same spot. Now we can have few more. So these two are equally spaced. Now we can set up some logic so that we slide between these basically. Head back into the character to set that logic. Under your BP character, if we press the right arrow, we won't do changeable controls. So right arrow, so right, and we can have left as well. So keyboard events left. Under right and left we can change them. So if we press right, we also need access to which target point we are at right now. We can have all of these in a blueprint. We can have these in the game state. Content, blueprints, game state. We can type in, we'll have an enum. It's going to be simple. So content, we'll create enums. So enum, right click, create an enumeration. And over here we'll call this one which side of the road you're in basically. So I don't even know what to call this. Which side, I guess. I mean, which is kind of stupid, but at the same time it's descriptive. So it's either going to be left. Okay, you're at the center by default, so I'll have center first. Center, left, and right. So if I save that and head back into my game state, now I should be able to create a variable of type which side, which side. So just my naming convention. So we'll call this one with side maybe. Alright. So we'll have access to this at any given instance. And on begin play we can store a reference to this. Get game state. We can go ahead and cast to our BP game state, and we'll have a reference to that. Promote that to a variable and call this one game state ref. Okay. Now from here, when we press right, we can first of all get access to the variables. The first variable which we need is the only variable which we have right now basically, which is the side. So we'll type in side and we'll do a simple switch. So if we are at the center right now, we can go to the right. If we are at the left right now, we can go ahead and head to the left basically. If we are at the left, we can head into the center. If we are at the right, we don't need to do anything. So basically on center and left, we can do that. Again, we'll copy over this logic. Depending on which side, we don't want to do anything if we are on the left side here in this case. And we can linear interpolate on tick. So linear interpolate is what we'll just do. So we'll type in lerp and we should find a linear interpolate and we should be able to feed in the alpha. We'll think about a logic for that. Now we'll have access to where we are. By default, we are at the center. Just took a small break there. Now over here, we can continue with our side switching logic. So we'll actually get hold of all the locations and stuff. So by default, we are over here. So if I press play, we are over here. But when we want to move to either this or this. So we'll actually have a few variables for this. I'm going to be hard coding this, but you can have a more elegant solution for all of these. So I can go ahead and under my game state itself, I can have right location, center location and left location. So I'll duplicate these. So I'll call this one left location and I'll call this one center location. And we'll manually set these values. So this value over here is -230, -270 and 0. This is the left location. So -230, -270, 270 and 0. We can actually save some data, I believe, by using floats. We only need we only need to linear interpolate the x direction. So we'll just store the x values of these. So this is 270, 20 and -230. Not sure if they're spaced equally. I'll just have a look at the top view. I want them to be spaced equally. So between this and this, there is a difference of 250. Between this and this, there is a difference of 250. So yep, they are spaced equally. Okay, so the right location is going to be 270. Left location is -230 and this is going to be 20. So I'll just store these like this. Now what I can do is I can go ahead and actually move the character. So I'll try set actor location. Not sure if this is going to work. So if we are at the center, we'll try to set this to the right location. So we are going left, so left location. So we only want to change the x. So go ahead and split the struct bin, change the left location, and the rest is going to be the actor's location itself. So get actor location. Go ahead and split this. Y and z will just remain as is. Alright, so we can go ahead and try this. So if I press the left arrow, so nothing is really happening here. So we can see by printing if something is happening. So nope, we are not actually taking the input. Something has to do with the input. So arrow, left keyboard, not really sure. I'll try to use A and D for now. So A on the keyboard. So we'll use WASD. So when I press A on the keyboard, we can try that. A is going to be instead of the left arrow. Alright, so we don't have access to the game state according to this. That's mostly because we didn't set it. So that's pretty simple to handle. So we can change that to BP game state. Now over here we can try the left arrow logic itself. So if I type in left, not sure what else we have. So left is the only thing we have. So we can go ahead and try this. So left arrow doesn't seem to work. Okay, left arrow works. So that was the game state issue, not our thing. So we can use this logic. We can linear interpolate instead. Or we have our interp nodes anyways. We can have a variable for the target location. So this is where we want to get our character. So target X location, just to be precise. So linear interpolate is going to be a little tough. So f interp2 is what we'll use. It's a pure function. So f interp2, f interp2 constant, because we want it to interpolate in a constant rate. So delta time is going to be delta seconds. Interp speed, we can adjust that. So we can promote this to a variable and we can call him sideways speed. Over here we can replace this with the target X location. That's going to be the X. Oh, this is an integer, we'll make this float. So target X location, and current is going to be our current X location. So target is our target X, current is our current X location. So current X location. So we can get the actor's X location again. Alright. So this should be it for the sideways movement. And over here we can go ahead and set these. If we want to go left, we don't want to do anything when we are on the left side. Alright, we can get the game state and we want to go left. So left location. And we can duplicate that, and if we are right, we can get the center location. Okay, but the logic isn't done yet. I'll get back to it. So we can use a select to just make things a little bit more simple. So if we are at the center, we'll go left. If we are at the right, we'll go to the center. So the logic should make a lot more sense now. And we can set this over there, move it in. Similarly, we can copy over this logic for our right. So that it simplifies things a bit. So if we are on the right, we don't want to do anything. We'll go to the center if we are on the left, and we'll go to the right if we are on the center. So get the right location. So this is what we'll set it to. Alright, now our logic should work once if I go ahead and press play. So if I put the left arrow, nothing really seems to be happening. Let's just check out why. Oh, okay, our interp speed is 0. Okay, so now if I try, alright, nothing really happens. So let's try 100. So our actor location seems to be fine. So current and target is okay. And now we can go ahead and print hello. So we're not changing the location, I assume. That's what's happening. So when I press the left key on the keyboard and when I press the right key, so we are changing the target X and the target Y location. So we'll try it without the interp first. A bit of debugging will so we can just copy this in. So I'll just remove this logic from tick. If I hit left or right, nothing really is happening. So we can print it and check what's going on. Alright, once again, the input isn't working. We'll use A. So we'll go ahead and use A on the keyboard maybe. Go ahead and use A. So if I type in A, the input, okay, it's just about the window being in focus. Alright, so if I go ahead and run this, okay, this works. Now we can try it with the interp logic. So now we don't need this. Okay, the speed is just way too less. So we can go a bit crazy on this, 50 maybe. Nope, still very slow. 200. Okay, it's still really slow. So 500. Okay, this is not going to help. Oops, it's going 50. So if I make this 500. Okay, this is a lot better, but maybe 1000 would be fine. Alright, so this seems about right. But now we need to change our actual state itself. So again, we'll use this select node right there. So if we are in the center, we have to set our side. So we'll grab a reference to the game state and we'll set side depending on where we are. So if we were at the center and we moved left, we'll set our side to left. So center, we'll set it to left. If we were at the left, it's going to be left itself. If we are at the right, we'll make this center. Copy over the logic. Okay, so for this, so everything will remain the same except when we are on the left and we go right, it's going to be center. If we are on the right, it's going to remain right. If we are at the center, it's going to go right. Okay, so now we can go ahead and try this out. So something happened with our logic right there. Okay, so we had to get the actor's location instead. We made it 0, so he just sunk under the ground. So go ahead, right, left, right, left, right. Okay, so it is a bit glitchy. It is a bit glitchy at times. So let's try enabling teleport. Sometimes that should fix the issue. Okay, when I'm at the right, he's moving to the center for some reason. So when I'm at the right and I click right again, so the logic is when I'm at the right and I click right again, I should still remain at the right. When I'm at the left, I move to the center. So let's try that. So I go to the right, click right again, I go to the center for some reason. So when I'm on the right, the target shouldn't actually be this, it should be the right location itself. When I'm on the left, this shouldn't be 0, this should be the left location itself. Because you're doing the interp on tick, so that's why it's happening. Left, right, and center. Alright, so now our logic is working totally fine. And we can stop printing hello, it's just annoying at this point. Okay, then I think we exceeded 1 hour. Okay, we're pretty close. But we are left with our last few steps. Now we have to make the obstacle move, which is pretty simple. Now we can spawn it dynamically instead, rather than spawning it, or rather just using this. I think we are spawning it. Yep, we are. So I can press F8, head into my perspective view. And now for the magic, head to the obstacle blueprint itself, course obstacle base. We can try this on tick. So on tick, we want to set the actor's location. So we want to change the location of this actor. We'll get the current location. So get location of this actor. So get actor location. And when we move forward, we are increasing the Y basically. So when we move forward, we are increasing the Y. So the logic was wrong. Okay, when we move forward, we are going more towards the negative Y direction. So what we can do is we can go ahead and move it backwards. So we want to increase the Y. So the X is going to remain constant. The X will be as is. Delete that. Split the struct pin. Z is going to remain constant, but Y is going to be Y plus, let's just say 1 times delta seconds. Let's try delta seconds itself first. This should remain constant for all actors because this is tied to frame rate. So I think it's moving, but it's moving very, very slowly. Yep, it is moving as you can see, but it's moving very, very slowly. So we can just go ahead and multiply this. So multiply this by some value. Let's just say we multiply this by 100. So not sure if, yep, there we have it. So as you can notice, it's not actually the character that's moving, it's the whole obstacle course which is moving. And what's weird is our character's actually following it even though we haven't actually attached him over there. Okay, so we can fix the X location of the character as well, because he seems to be just sliding along. So there is actually a setting somewhere here. So it shouldn't slide along the surface. So something over there. character movement maybe, and there is something over here. Okay, ground friction, let's try 0 on that. Okay, we are just still moving back. So if I hit F8, actually the whole thing is moving back. So instead of that, we'll just set the location, the X location every time to be constant, or rather the Y location. I'm not sure what it was, so we'll copy it. So Y is negative 270. So negative 270. I don't want that to change. And as you can see, our logic is working. And it seems like we are moving forward. The speed is something which we can worry about a bit later. So maybe make this 300. And as you can see, it feels like we're actually moving, but what's actually happening is the whole course is just moving. The character is actually standing still. So now our man is going forward. We can finally go ahead and set up the obstacles itself, I guess. And add in a jump state, obviously, because right now he doesn't jump. So we can adjust the speed, maybe 350. A little more quick would have been nice. Go ahead. Okay, with that, something we'll worry about later. Now, for our next step, so I don't think we really require teleport. So our X, Y, and Z is all set. So for this, we'll be using the jump as well. So we'll go ahead and create a binding for our space bar, and we'll call this one jump. And when I release this, we are going to stop jumping. Okay. So now we should in theory just go up. We can adjust the settings of the jump under our character movement component, and we can also have animations. So under our animation blueprint, we can set it up. So content, blueprints, game, character, anim BP. We can ignore these and we can add a state, and this is going to be jump, jump start, and jump loop. Jump loop. Alright, so jump start, jump loop, and we'll see what animations we have. And from our jump loop, we want to go back to our run animation basically. So jump start is going to be our third person jump, and for the transition, we'll check if we are jumping. So if we have our character reference here, so is there any variable? Not sure. We can try this. Okay, nothing's really happening. Okay, we are getting a runtime error saying we don't have the character ref. So we'll only access this in the anim graph. So go ahead, if this is valid, we'll go ahead and okay, we can check if this is not valid first of all. So we only get it once, and occasionally it's going not valid. So we can promote this to a variable and call this one jumping. And in our transition, can set it up. Okay, so the variable isn't doing anything. So we can head back to the character and create a variable for it in the first place. So jumping, Now we can go ahead and set this to true. We can go ahead and set this to false as soon as we release it. Get jumping. Okay, this logic should work. This is jump start to jump loop. So when our time remaining for our jump is less than, let's say, 0.05 seconds, we'll enter this transition. And jump loop to third person run when this jumping is false, basically. So not boolean, I guess it's called. So we'll just invert the value. Now if I go ahead and press space, okay, the animation is weird. So we can again do and maybe, and if the jump loop has at least played once. So jump loop. So we can get access to the jump loop here. So time remaining for the jump loop is less than 0.05. We can try this logic. Okay, we just went into a completely random state there. Again, probably some logical error. Okay, so in our jump loop, we haven't fed the animation. Okay. So our jumping logic is working. So we can change this to maybe something a little more smaller. 0.02. So this is going to feel a lot smoother. Okay. So we are jumping. Now we can start adding the actual obstacles. Under the course, we can head into obstacle base, and over here we don't want anything. This is not something we'll actually be spawning, obviously. Obviously what we'll spawn is going to be these. So under obstacle 1 we can have stuff. I'm not even sure at this point if we're able to see the sides. We're barely able to see it. And we also need to destroy it once we actually reach a certain point. And we also need to keep spawning it, basically. So wherever our player start is. So let's go ahead and add a trigger volume. So trigger box. So the X is going to be 20. The Y is going to be whatever this is, and Z is going to be 0, let's say. And we'll just increase the extent of the box, maybe 500, 500 and 500. Okay, and we'll set the hidden in game to false. So hidden in game is false. So F8. So this can go way ahead. So a little more. So we can select this trigger box and we can do ×2. By the way, that's a pretty handy thing which you can do in Blueprint. So just a little bit more. So more. Okay, I want to simulate now. So go ahead and simulate. Okay, so as soon as we end overlap on this, we want to spawn a new one. So go ahead, on actor end overlap. On actor end overlap trigger box, we'll try to print first. Okay, so as soon as we go out of this, first of all, for the last index, we'll go ahead and promote this to a variable. So we'll call this one last spawned obstacle. So we'll always have a reference to that. Go ahead, copy this over. So spawn actor, we'll make use of this. Remember we had our arrow component. So the arrow which is there opposite to the origin is what we need. Game course obstacle base. So near the origin we have an arrow, and over here as well we have an arrow. We'll make use of this arrow. So the location of this arrow, so this is called arrow 1. So we'll call this one end. So that's a little more descriptive. Under the level blueprint now, so we'll get the end. So get end. So get end, and from end we can get the location. So get world location, and we can probably copy this over just like that, and we can change this to this, and the rest of the logic should actually work just like that. Okay, so now if we actually wait for this, as soon as this goes away, one more is going to be spawned. But there's another thing, we want to destroy it once we actually go after a certain point. We want to actually just destroy it. Like once we are behind the player, we have no reason to still have it, so we can have a trigger box for that once again. So 500, maybe 500 and 500. Go ahead and over here as well, we'll set up begin overlap for this instead. So on actor begin overlap. So begin overlap, on actor begin overlap, destroy actor. Okay, let's try this out. So I'm not sure where this box is. Let's unhide it. So hidden game, set to false. Okay, so in theory we should be destroying it. Okay, we destroyed the box itself. So other actor is what we have to destroy. Whoops, we need to take this a little more further back. So now if we wait for it to reach there, so we are continuously spawning the box over there, and if I actually head back into my view, I cannot see anything happening, and our world is spawning normally. How cool. So over here we can add a couple of things. So obstacle 1, we can add a few shipping containers maybe. Oh, we can make it random. Actually that would be nice if we just make this completely random. So somewhere at the center, I'm not sure where the center is. I think it's negative 1600. Well, this is where the center is going to be. Oops, I moved the end itself. So first duplicate it. And this is going to be negative 1600. This is going to be center obstacle. And we can go ahead and duplicate this. And this is not going to be called center obstacle. This is going to be called left obstacle. And we can call this one right obstacle. So our right obstacle is going to be to the right, obviously, and our left obstacle is going to be to the left, obviously. So this is 250, this is negative 250. Okay, so we have set that up. We should have done this in the base actually. So we'll cut this and we'll paste this in our base. So don't mind that. Now we should have our obstacle both in the base and the others. And obviously the logic is going to be in base itself. So since we are randomly spawning it, it's totally fine. We can use the base itself, I assume. Now in the event graph, on event begin play, we can go ahead and create a static mesh, or rather spawn a static mesh at that location. For that we'll need a few actor classes. So obstacles over here, we can delete these, and if we play, everything should work. However, under this folder we can make a few actors actually. So obstacles, we'll call this path actually, path underscore base, in case we need any derived classes. Now click on blueprint class actor, and this is just going to be obstacle 1. Few will be dodgeable, few will be not. So we'll make dodgeable and non-dodgeable obstacles. Dodgeable, we'll just have 3 for each. We'll create childs. So child, control D, and we'll name this one child 3. So 1, 2, 3. So this one is going to be non-dodgeable. So we'll go ahead and create a child, control D, and this is going to be child 3, obviously. Okay, so finally we can go ahead and add stuff to these obstacles. So obstacle dodgeable child 1, we can, instead of the default scene root, obviously, obstacle dodgeable here as well, we'll simply have a static mesh. So static mesh, so that's done. I will leave the root, it's fine. And we can look for some stuff here. So we have quite a few meshes. So we can have a barrel in one place. So we can have boxes, we can have barrels, we have so many options here. So we're going to select this, let's say. Let's try this. So in path, we want to spawn actor from class. So for the class, we'll make this obstacle dodgeable. So spawn transform is going to be this. So oops, Center obstacle, let's try this first. So center obstacle and get world transform. Go ahead and try this out. Okay, it's just sliding along for some reason. And we want to attach it, yeah, that's the reason. So attach to component. We want to attach this to our actual plane, or we can just do it for the root component. So now in theory this should work. Okay, so this seems to be working fine. One more thing, we can make this a bit faster actually. Now we can promote this to variable, so speed. So we'll make this one 500. Okay, as soon as we hit something, we should stop and our game should get over. So we'll have event hit here. First we'll print something. Go ahead and test this out. So if the other actor is an obstacle, pass to obstacle. We should have made a base class, to be honest. Go ahead and head into content, blueprint, game, course, obstacles. We'll create one called actor of type obstacle base, and we'll inherit these from the base classes. So class settings, so obstacle base, and these will also change. So we'll inherit this from obstacle base, so obstacle base. Alright, so we can go ahead and cast to obstacle base, and we are going to print, or rather we can just exit the game. Execute console command and we'll type in exit. Let's try this. Okay, our logic is working. Okay, we still hit it. So we need a better jumping logic. That's the problem with our jumping logic. It's not our obstacles. So under this, we can go ahead and change stuff in the character movement. So under jump, we should have this parameter here. So if we change this to 500 for example, so now we are able to dodge this obstacle successfully. And they're a little bit too far apart, I believe, these obstacles. So what we can do is we can have two actually in each one. So go ahead and select all three of these. So I'm not sure what 75% of 3200, so 0.75 into 3200 is going to be 2400. So at negative 2400 we'll have it, and we'll go ahead and duplicate this. So these, and we'll have these at 800. So we'll have a gap of 1600 between each obstacle. And now if I go ahead and press play, we have to set up more logic actually. So we are spawning the obstacle dodgeable here. Now we'll make some non-dodgeable obstacles as well. So set up the non-dodgeable one. We can have something like a shipping container or something. So the way I do it is going to be, if I add in a static mesh once again, and we'll have a shipping container, maybe container. Okay, we have quite a few. That's nice. Let's try with only the non-dodgeable one. Non-dodgeable. The rotation's off. Go ahead and rotate it by 90 degrees. Okay. So this is not exactly on the floor, but we can fix that. Head into the left view. Okay, it is on the floor. Not sure why it's not on the floor over there. Can try just moving it a bit. That about fixed our problem. And we obviously should be able to move aside and dodge it. So we are spawning obstacles, and now we can set up a little bit of logic to make this random a little bit. For dodgeable we can have few more. So for dodgeable we'll leave it as is. Child 1, let it be as is. Child 2, we can make something else. So this static mesh can be, we can look over what we have here. We can have this roadblock thing and change the logic obviously. So dodgeable, I think it was child 1, so child 1. Child 2 rather, child 2. Open it up. I mean, it is a bit down, but you get the point. So change that 10, 20. We'll just move all of those by 20 units. And for the third one as well, we'll just add one. Now obviously you can go ahead and make more of these. I feel like if we have some sort of a traffic cone or something like that, so I'm just looking for what I can have. So okay, these seem like the perfect choice. Let's try that. Again, forgot to change it. So under my path, so course path base, we can go ahead and change this to child 3 to test it. Again, it's a bit low, but that's not an issue. Okay, I forgot to get the window in focus once again. That's my fault. And we have to move it down, I believe. So move it down by 20 units. Okay. So we have our dodgeable obstacles. Let's set up our non-dodgeable obstacles as well. So in our child one, we can again look for what else we have. Maybe if we have a truck or something. Nope. We can look for what we have. So construction volume 1 meshes. So can have a fence. Yeah, that's not a bad idea. So this is child 1. So let child 1 be the same. Let's actually open up child 2 and let's actually open up child 3. So these are the ones which we'll try to change. Over here, meshes, we'll select the fence for one. The rotation can be 0. Change this. Non-dodgeable child 3. So it's a little too big. So we can scale this down, maybe 0.8. Okay, so I don't think you can dodge this one. Okay, we can dodge it when we move aside. So we'll just have one last one. So for this one, so obstacle child 2, we'll change it right now. So child 2, these are the various obstacles basically. Non-dodgeable child 2, select that, and this is child 2 I assume, yep. So we can look for something else which we may have. Okay, this looks like something interesting. Oh, light generator, whatever this is. Let's try that. I don't think this should be something which you should be able to dodge. Okay. So that works. Now we can set up some randomizing logic so that we spawn everything in random. So this logic is the same. We need to select the class basically. First we can select a random integer. So random integer. So this is going to be the number of random integer in range actually. So this is going to be the number of dodgeable obstacles. So we need at least one dodgeable obstacle, otherwise the game is going to get unplayable. So we can either have one or we can have all the way up to 3. And what we can do is, depending on the number, now this is going to be number of dodgeable obstacles what we have. So promote this to a variable. So number of dodgeable obstacles. Okay, so now that we have this, if we have only one, what we can do is we can select one. So number of dodgeable obstacles. So we can switch on int and we can select something. So we can start at 1. So start pin at 1. If we have only one obstacle, our logic is going to be really simple. So we'll just select a random one over there. We need to do this 2 times by the way, or multiple times probably, I'm not sure. So we'll have more obstacles, to be honest. These are not enough. So we'll space them a little more closer. Copy these. Right obstacle, left obstacle, center obstacle. Control D to duplicate, and left obstacle 2, where's center obstacle to? Okay, we didn't duplicate everything. So center, left and right. So center, left and right. Control D to duplicate. Okay, we aren't duplicating anything, we'll just duplicate these. So, okay, left, center and right. Can move this somewhere in the center, right at the center. And we can space these two equally apart, which I believe they already are. Are they equally spaced? Yep, but we need to space them out a bit more. We have 800 for the spacing here. So we can select our obstacle 1. We can try giving, negative 600 maybe. So if I do negative 400, so that will be way too much space. 500, maybe we can try 600. So have 3200, let's divide it. Let's take 33% of that. So calculator. So it's somewhere around 1066. So we'll have 600. It's fine if they're not equidistant. You can obviously do the math yourself. So obstacle is what we need. So 1, whoops, 2 and 3. So 3200 minus 600 is going to be 2600. Okay, now let's see if this works. Yeah, obviously we are not spawning it, that's different. But now, in theory, our logic should work. So we can actually loop through. So we can select the number of dodgeable obstacles for each level. So we'll have an array of this. So we'll create an array. So change the type, it's fine. So we can do a for each loop. And for each index, we can try and get a random integer. So we can set array element. So this is the index. We can do a simple for loop. So for loop. So from 0 to 2. So size to fit, we'll do that. And we'd actually want to reserve 3 locations. So 1, 2, 3. So we don't need size to fit. So in this index, we are going to set this item. So for all our 3 levels, we know the number of obstacles which will be dodgeable. Once we have that number, we can go ahead and spawn them. So we can have this in an array and randomize them actually. Anyways, don't worry too much about the logic. It's just my logic which I'm making up. We can select this. So we can store these in an array. So create an array. So promote to variable. Or we can actually just have an array. So what are we using this for? We are just using this for the location. So we can get the transform of this. We can only have the transforms in the array. That would work, I guess. So first we'll have the transforms. Go ahead and create an array for transforms. transforms 1, transforms 2, transforms 3. We'll need 3 arrays. So the location is enough for us. So array of vectors transforms 2, transforms 3. I know I shouldn't be calling them transforms, but we'll take a look at the right obstacle. The first level ones basically. So we have this selected. So right obstacle 1 will go according to naming order. Transforms 1. We'll compile this blueprint. So we have 3 elements. We can access it right here. So the first one is going to be this. I'm not sure if we can paste this. Yep, we can. We have right obstacle. Copy this. Okay, we took that. So left obstacle. Copy this and okay. The right and the left have, okay, they don't. So paste one has negative 250 and the center one will probably have 0. So we'll paste it. We'll have 0 over here. Okay, and now that we have this, let's grab our obstacle 2s or obstacle 1s. So this is negative 600. 1, 2, 3, negative 600. This will be constant. So one is going to be 250, another one is going to be negative 250. Similarly, we can grab our 2. So negative 1600, this is basically our midpoint. Negative 1600, 250, negative 250, and this is about it. Now, once this is done, we'll collapse this to a function. So determine number of dodgeable obstacles. Okay, we have the number of dodgeable obstacles now. Now what we can do is we can loop through this. So for each loop, I really wish we could have a 2-dimensional array for this. That would have helped us a lot. Now what we can do is we can go ahead and randomize this. Can we not randomize this? Okay, we cannot. So we have a plugin which will help us. So low entry. We can restart. Save everything. Alright, so back here, I think now we should have, okay, we're coming close to 2 hours. I think this will be done in 2 hours, not 1. Blueprints, game, course, path base, and we should have a randomize. Oops, nope, we don't. So I think we might need a few functions. So how do we go about randomizing this? We can look at the Epic Games Launcher if we have any plugins. So array helpers, I guess I had one. So we'll go ahead and install this to the engine. We can simultaneously use it. Once we have this, so once we actually randomize this, depending on this, we can go ahead and set this. So switch on int and we'll use select for this. So just close the editor just to let that happen. And now if we go ahead and launch our endless runner, Okay, go to edit, plugins. So edit plugins and array helper. Go ahead and restart. So this is the sort of stuff I just hope it doesn't take too long. Right, hopefully we have some sort of a randomize function. So randomize. Okay, we still do not have a randomize option. So let's just look for it. So randomize array unreal. I don't know. Is it just called something else? So okay, never mind. It's called shuffle. So first of all, we'll shuffle the arrays. We'll shuffle all the three. We'll do that before we actually set this. We'll go ahead, shuffle this. Go ahead and shuffle this once again. We'll put that in the previous function itself. So we can go ahead and shuffle. Generally, I don't recommend you guys do array operations in Blueprint, but anyways, once this loop is completed, we can do that. And this will go to the return node. Just for you to understand the flow of logic here. And now, depending on this, we can go ahead and spawn them. So the array element is going to be the number of obstacles. So this switch is going to start from 1. So start index is 1. You'll either have 1, 2 or 3. So if you have 1 or 2, we can use select probably. Copy this over. So everything else is 0, so we can just leave it as is. So we can go ahead and over here, if this is 1, if we have one dodgeable obstacle, we can go ahead and spawn just one of them as dodgeable. So dodgeable. So 1 is going to be dodgeable, and the spawn transform will just use the first index. So we'll select. So depending on which index it is. So transform 1, transform 2, transform 3. So option 1, option 2 and option 3. So we'll select any one of these arrays. And if we have to spawn only one dodgeable, so we can get a copy of the first one. We'll split the struct pin here and we'll just get this location. Now we need to just repeat this logic. So Control D, and we want to do two non-dodgeable ones. So dodgeable, and index 1 and 2 are going to be non-dodgeable. So non-dodgeable. We have to spawn a child class of this. So can use the select once again. So random integer, and max is going to be 2. So it's going to be max is 2. So 1 and 2. So it's random number between 0 and max minus 1. Let's just use random integer in range. It's a little bit confusing. So minimum is 0, maximum is 2. Okay. And this is going to be dodgeable. So dodgeable, obstacle dodgeable child 1, child 2 and child 3. This is what we have done. And for this one, this is non-dodgeable. So we'll copy the logic, but instead of dodgeable, we'll have non-dodgeable. So child 1, child 1, child 2, and child 3. Okay. And we need this once again. So copy over this entire logic. Alright, so this is going to be the same. This is going to be for index 2. Now, if we have 2, we can go ahead and copy this over. So Control C and Control V. And we can just move this aside. So for index 0, it's going to remain the same. Whoops, Control V. Oops, copy this. Control C and Control V. Index is still going to remain the same. Once this is done, we need the attach as well. We didn't copy over the attach. Okay, so we have to duplicate this whole thing. So index is this, and index is going to remain the same everywhere. So now we need 2 dodgeable obstacles. So for this one as well, we have dodgeable, and this is going to be index 1 obviously. And for index 2, we can go ahead and have this. Alright, so copy this, and again we can pass the index. So array index, go ahead and pass that in. And when we have all 3 dodgeable obstacles, we'll just go ahead and copy this much. Control C and Control V. So in case of 3, this is what we'll do. So index is still going to remain the array index. Control D and Control D. Copy this over, move the execution pins, and the index will obviously just remain the same. So the last one is going to remain the same, and this is going to be 2, this is going to be 1, and this is going to be 0. So make sure you have 0, 1, and 2. Okay, so now our logic should work, and if I were to go ahead and press play, okay, everything works. Okay, alright, so we stepped on to something. We need to make sure this doesn't happen in our first run. So okay, we have to just ensure that the obstacles aren't spawned in the first one, basically. So we'll create a boolean first box. So if this is not the first box, we'll go ahead and do this. So inside the level blueprint, under this, if we go ahead and refresh nodes, we have to pass this in. So expose on spawn. Alright, so now if I refresh, I should get this. So only if this is index 0, so double equal to 0, then this is the first box, otherwise it's not. Okay, so now our logic is working. Let's go ahead and play the game now. Alright, so as you guys can see, our game is working as expected. We don't have a score yet, we'll just set it up quickly. So as you can see, our logic is working. So we can set up a scoring system real quick and dirty here. Content, we'll do the start thing also. It's really simple. So go ahead and open level. We call this one game map, I believe. So maps, game map, go ahead and paste that in. We can start from the main menu. Go ahead and play, start, and we started the game. So as you can see, everything is working as expected. You could have some stuff at the side. And we'll have a scoring system. We can have a time-based scoring system. So the score is going to go up at a constant rate. Content, we'll create a widget for it. So use a widget, and we'll call this one HUD. And we'll just simply have a text. So we'll wrap this with a canvas panel, and this is going to be our score. Once we will set the game mode and stuff. So game map. Here we'll have BP. We don't have a player controller. We'll create that. Game. Go ahead, head into blueprint class, player controller, BP underscore player controller. So you should have BP player controller. So on begin play, we can go ahead and create the widget. So create widget. It's going to be HUD, and we can go ahead and add to viewport. Right, so let's look at our time. We don't have much. I think it'll take probably just a little over 2 hours, but it'll be done. So once we create this, we can grab a reference. So promote this to a variable, and we'll call this one HUD. Now I don't recommend you guys use bindings, but I think in this case, just to make this real quick, I'll use bindings. So we can have game state. On construct, we can get reference to the game state. So get game state, cast to BP game state, and what we can do is we can grab a reference to it, and we can create a score variable. Content, blueprint. We have blueprint. Main menu, I guess, no, game. So game state, and we can have a score. So we'll make this an int 64 so that we can have larger scores. So int is a 64, and we can have a timer. So set timer by function name, and it's going to be something which happens every 0.5 seconds, let's say, and we are going to increment the score. So promote to variable, score timer, and we can have a custom event, increment score, or increase, I'll call it, doesn't matter, we'll not worry about that. We are going to get the score, and we'll set it to score +2 maybe. Plus set score. So we'll go ahead and do that. Copy this, put it in the function name, make this looping, and we can use a binding here. So we can bind this. We can get the game state. We can make this a validated get. This is a little more expensive on your computer, so don't do this. So we can get the score, and we can convert this to text. You can use a format text node and stuff. I'm not really going over that, so we'll just do that actually. So format text. Alright, and we don't need to convert this. If we press play, as you can see, our score is increasing at a constant rate, and you can see it on the top left hand side. For those of you on mobile phones and who are not able to see it, I'll just make this text a little bigger. So 40, make this one regular, we don't need bold, and this should be good. So as you can see, everything is working fine. And you can go ahead and set up any logic if you want to, like, save it or whatever. But for now, I'm happy with this. So that's it for this video, guys. Thanks for watching. We do have a complete game, and instead of exit, you can just show the score on a widget or something. We'll do that. Let's not leave it halfway. The last part before we just complete it. So we'll create a widget, and we'll call this one end screen. Okay, we'll add a border, wrap this with a canvas panel. So we can go ahead and wrap with canvas panel, and this border should take up the whole thing. So offsets are going to be 0, and the brush color is going to be something black maybe. And we can just go ahead and add some text. So we need to align it right at the center. So vertical box, we can use an overlay rather. Overlay is going to be helpful here. So overlay. So border is going to be filled. The overlay is going to be filled as well. So 0, 0. Alright, and over here we can have text. And this is the advantage of using a canvas panel. So 40, can make this regular maybe. Can go ahead and put score, and we can go ahead and give the value. So let's go ahead and set that. So event construct get game state, cast to our BP game state, and we can get access to the score variable, get score, and we can set the text of this. So set the text, set text, and this is going to be about it. We'll format it. So format text, so this is the score. So let's go ahead and center that, make it 0.5, 0.5, and make everything else 0 here. Oops, the size shouldn't have been 0. Make this one center aligned, and make sure for any vertical alignment which we have. Okay, nope, we don't, so I'll just reduce the size of this maybe to 100. Okay, this should be good. Now if I go ahead and press play, nothing will happen because we haven't spawned the end screen. Where we have our event hit in our character, so we can cast to obstacle, and instead of that we can go ahead and create a widget. Create a widget, end screen, and we can add it to the viewport. Alright, let's go ahead and do that. So I'm testing the end screen, so I'll just die immediately. Okay, so our score is 300 apparently, which is nice. Okay, not sure why we didn't exit immediately there. We need a do once. I understood the problem. So do once. Because once we die, the game's over. Don't want to redo that. So okay, we need to do once from here actually. No, we just went over the obstacle, which was kind of stupid. So go ahead and try this out. And our score is 280. So that's it for this video, guys. I hope you guys really enjoyed this entire course. I know it's been over 11 hours at this point, but hopefully you've learned something new, and I hope you enjoyed the last part where we actually made an entire game and we didn't use any C++ to be honest. So that's about it. Hope you guys enjoyed and see you guys later. Goodbye.